everybody, welcome to the third video in our series on Pythonic code. In this video we're going to be introducing lambda functions. Now if you remember back to function handles in MATLAB, these are going to be very similar. And let me start by just talking for a little bit about what are lambda functions and why would we want to use them. And I'll also give a little bit of a caveat. So maybe I'll start with the caveat is lambda functions are sometimes called nameless or anonymous functions, and the reason is that they're often used without giving them a name. So kind of you write the code for it in a single line, it's a function and it doesn't have a name. So for that reason it's called an anonymous or nameless function sometimes. And in a lot of settings it's kind of best practice not to name your lambda functions. But for the purposes of this video and kind of just seeing how they work, you will see me naming lambda functions, and I just want you to know that in practice, that's kind of not the best thing to do. So that's kind of the first disclaimer. Kind of a little bit about lambda functions. So kind of the key idea is we can have any number of arguments to the function, but kind of when we write it, it has to take up just a single line. So we're going to see a comparison with a regular function, and kind of one big difference is, well, a regular function can take as many lines as we want, but a lambda function has to live on just a single line. And kind of, well, why would we want to kind of use a lambda function? Well, you'll kind of see, especially in our first two examples, like cap and plus, these are pretty simple functions, and maybe they're only going to be used once in a piece of code. So kind of instead of defining a whole function to deal with it, just define it in a single line and call it a day. And similar to function handles, we can also use lambda functions as inputs to functions. So for that reason, we also like to use them. So let's start by looking at this first question here. So it's saying write a function cap that takes as input a string s and as output returns the same string s capitalized. So let's first start by remembering how do we do this just in the regular old way. So we can say def for definition, and we can call it cap. We know it's going to take an input s, and we know it needs to return s and it needs to be capitalized. So there's our function cap, and let's test it out. I can do cap of, let's say, Yasmin. Oops, and string object has, did I spell something wrong? Let's see. Oop, I think capitalize. There it goes. So you can see here, Yasmin gets capitalized. But something to notice about this function is the return statement and kind of the entire thing that we do in the function is just on the same line as the return statement. So this is a good situation where we'd like to use a lambda function because it's just a single line, very simple, kind of no need to write out a whole function. So let me show you the syntax for it. The way it works is similar to how in MATLAB we used the @ symbol to let MATLAB know we were going to kind of define a function handle. The way you do it in Python is with the keyword lambda. And then you type the variables that are going to be involved. So in our case, we're going to have s, and then we have colon, and we say s dot capitalize. And if we'd like, we can call this cap. And let's try it out. So now I can try cap of, let's try hello. And let's see, I did it again. I keep saying capitalized instead of capitalize. And we can see here, it gets updated to hello. So that's one example. And again, the syntax is you type lambda, then your variables, colon, and then what you want the function to do. And again, the function has to be just one line. Let's see, another thing that I could do, let's try the next example. So write a function plus that takes two inputs and adds them together. So let's try it with a lambda function. I could say, let's call it plus equals lambda, and it takes two inputs. So let's say x comma y. Colon, and then what does it return? Well, it returns x plus y. So for example, let's try plus of 5 and 3. That gives 8. Let's do it with something like strings. I could try plus hello and world. And we get here hello world. So two kind of silly examples. Kind of we can capitalize things and kind of add things together without using a function, but I just wanted to introduce the syntax. This next example is going to be a little bit more involved, so let's kind of take a look. So make a 20 by 3 NumPy array of random letters, then concatenate each row of 3 letters into a single length 3 string using np.apply along axis. So okay, that's a lot. First thing we need to do is import NumPy. So I'm going to say import NumPy as np. then what we need to do is, okay, we need to create a 20 by 3 NumPy array of random letters. So since we're going to be dealing with randomness, let's actually instantiate a random number generator. So RNG equals np dot random dot default underscore RNG. And kind of you might be wondering, well, how do we get these random letters? So let me kind of show you a way that we can do that. So there's this thing called the string module, and it comes already with Python, so you don't need to install anything. And what we can do is we can say import string. And okay, but maybe you're wondering, like, what kinds of things does the string module have? So what I can type is dir for directory, and then string. And we can see here, not too many things. We have ASCII letters, ASCII lowercase, cap words, digits. What we're going to be interested in is ASCII letters. But before we go there, one thing I might want to show you is, so kind of the things available from string, there aren't that many compared to something like NumPy. So if I do dir of np, for instance, you can see here, look at this scroll bar. Look how many options we have. So just wanted to show you that. Let me delete this cell. We don't really need it. What we are going to be using is ASCII letters. So what I can do is say string dot and then ASCII underscore letters. And we can see here, okay, this gives me what I want, but notice, well, okay, I'll leave it like this for now, and then I'll show you kind of, there's going to be a small issue in just a minute. So remember, what we want to do is we want to choose random letters and put them into a 20 by 3 NumPy array. And the way that we can do that is, let's say, maybe I'll do it like this, np, or not np, rng dot remember choice. Then we pass it the list of things we want to choose from. So maybe I'll call this letters. So I want to choose from letters. And I want the size to be, what, 20 by 3. Now there's going to be an error if I run this. And the issue is that, well, it's a string, right? Like when we looked at letters, kind of this whole thing is just a string. Well, how can we kind of get it to a list? It's really simple. We can just cast it to a list. So now we can see I have my 20 by 3 NumPy array with random letters. So, okay, that's looking pretty good. Let's call this ARR. And just so we can look at it, let's have it here. Now, what did we want to do? We wanted to concatenate each row of 3 letters into a single length 3 string. So before we kind of do it for the whole array, let's see, like, so for instance, if I look at ARR of 2, for instance, so remember, this returns me the second row, so 0 row, first row, second row. So we have ZFZ. And then what I could do is, what if I tried something like, I take this and I do, okay, join, or kind of, yeah, dot join. And I call it on this entire second row. So do you see here where it has Z, then F, then Z? And what it's done is it's just smooshed this second row together. So that's what we're going to want to do, but now we just need to apply it to the entire array. So let's see how we can do it. So remember, we have np.apply along axis. And if you need help or a refresher on the axis argument, I definitely recommend watching the videos corresponding to that topic. But let's see. So the first thing that we're going to need to do is we're going to need to tell NumPy what function are we using. So let's not worry about that for now. But let's specify the axis we're working along. And notice we're collapsing in this horizontal direction, right? Like I want to combine in this horizontal direction. So that should be axis equals, pop quiz, should be axis equals 1. And what's the array that we're using? We're using array ARR equals ARR. Now, if you tried running this code without this kind of keyword ARR at first, it would throw an error just because we used the axis keyword here. So all keywords after have to be used as well. So now all that's left is, well, we just need to say what are we doing? What's the function? And we're going to use a lambda function. So we're going to say lambda. Let's call the variable row because we're inputting a row. And what do we want to do? Well, the same thing that we did here. We just want to join the row. So I'm going to say 2 dashes or kind of quotes, join row. And we can see here, what was the 0th row? We had KDI, there's KDI, PFI was the last one, PMS, YIT. So looks like it worked, so yay. Maybe last example, so we have this tuple list. It's a list of tuples where first entry is a string A, or a string, and in this case it's A, and then second is an integer. And let's say I want to sort it so that the numbers are increasing. So this I could very easily see being like a type of real world problem, right? Like you have some list of things and you want to sort based on some part of the list of things. So let's start by taking a look at the documentation for sort. So, and I think sorted is what we want. So, okay. What this does is, okay, so we need to put an iterable. Almost anything we've been working about, or not almost anything, but basically if it can go in a for loop, that's good enough for us. So iterable, we're going to be iterating through a list. That's fine for us. Then what this dash and star mean that after this, the keywords need to be specified. So we'll keep that in mind. Now, the key here is a custom function that we sort by. So for instance, I want to sort by these numbers in the tuples, right? So that's going to be our function. And then this reverse keyword tells us whether or not we want to sort based on ascending or descending order. So let's see how we could do this. So I'm going to want to do sorted of, and now we're iterating through tuplist. Now, has anyone noticed what haven't I done? I have not defined tuplist in a cell yet. All right, there it is. So, okay, sorted tuplist. Now, maybe first let me show you one example. So like, let's say I do tuplist of 0, for instance. And we can see here, I get, okay, A, comma 50. And what do I want to say? Basically, we're going to go through every element of tuplist. So this is the first entry. And then if I call, what's the first element of that, for instance? We get 50. So remember, sorted is going to go through every element, so every tuple. So imagine that the input is a tuple, and we want to take the element in this first position. So sorted, we're going to iterate through tuplist. The key is going to be a lambda function. So lambda, think of it as the tuple. That's our variable. And we want to take tup of 1. So we want to sort based on these values here. So I want to sort, so basically 45 is the smallest, so D will come first, then 50, 70, 100. So let's see it. And just like we said, so we have 45, 50, 70, 100. There was also this reverse keyword. So let's try it. Let's say reverse is equal to true. And we can see here it goes in descending order. So we have 100, 70, 50, and then 45. So in this case, because we were saying tup of 1, we were sorting based on these values here. But we could also sort based on the letters. So let's try it out. So again, instead of tup 1, what should we have? Tup 0. And we can see here, it's going D, C, B, A. Then we could put false. And we get A, B, C, D. So I think this is a good place to stop the video. Thank you for watching, and I will see you in the next one.